And there we go. I think we should be live. Just give me a second. There we go. And on YouTube. Yep, now we're live. Perfect. Just mute the stream. And we're going. So, in this stream, you read the thumbnail. I will design a robotic arm. I started last stream with designing, or I had a few designs done, like this right here. I did this in the last streams, I designed the grabber for my last robotic arm, but it was just a bad design. You see right here, the gears then. That's what we designed last time, but I want to start from scratch with gained knowledge, and that's what I want to do now. So probably most of the time will be spent just sketching up most of this here. Let's just clean my desk up a bit. To-do list. And there we go. So just a simple robotic arm. My last design, I can just quickly show it on the stream. I designed it in Onshape, which this time I won't use. I downloaded a new software called FreeCAD, and I played around with it this week a bit, and I quite like it because you don't have to have a web browser, and my Wi-Fi is not that good. So I had a lot of problems when I tried to had bad Wi-Fi but still wanted to design something. So yeah, switching to this. You see the base right here. The motor would be mounted in there, the robotic arm here. If we go into the assembly, you see what the idea was. The motors would be mounted in here, just as the one up here. But the problem with that was, first of all, it looks shit, and second of all, I would have had to design a specific system for that, which would be unnecessary. So this time the motor will be mounted directly in the center, without needing to make some wires to connect those two. Then in the bottom here, I also want to redesign the mount for the stepper motor, which is this right here. So it just has a bit more space. I'm not sure if I will use this stepper motor for the design or for this today, but I will probably take like 2 or 3 weeks to design this whole thing, if not more. And then I'll see if I maybe upgrade this because it's not that powerful, and we see how it fits in there, and then we'll improve on that. So today what I will do is come up with a new design. I have a few ideas in my head, but I haven't drawn anything down so far. So first of all would be the side sketch. We have our base right here. In the base will be the Arduino, it will be stored there. And then the first stepper motor, the stepper motor, but the stepper motor will be stored in there. On top will be a small disc that rotates, where the first motor will sit. This is the thing I have right now, but instead of here, you already saw it broke out down there. So yeah, this disc will sit on top of here. Also it has a little hole, which I think it worked okay with the stepper motor. I can just quickly set this up. Wait, let me see. Where's the motor? There's the motor. If we just go ahead, wire this up. connect the power to it. The Arduino. It just is a script that rotates, and now you see it. It is just rotating the disk. So this would work. It's just a bit sliding around because I didn't design the hole too good. You see it has a lot of room in there to move. You actually see it, it's like falling around everywhere. So probably, or I have to redesign that. So I will see how this turns out. Then let me just see. Stream data like this. So we'll just make the motor now here. The stepper motor will be mounted in the center. I don't know if you can even see what I'm drawing down there. See, there's the base where the Arduino is housed, and on top of that is the stepper motor. Here will be the servo motor mounted. Last week I experimented with the motor mount. It was quite okay. Here just assembled this just to see if I designed everything correctly. Yeah, so this will be on top of the mount then. So somewhere like here. Then yeah, just be secured like that. Then here will be the second arm. It will just be stuck on this. And that's what I'm gonna draw quickly. So we have our rotor right here. Then, and I also think that I won't make this robotic arm to this large as I made this one, because I want to make a bit more structure here, because you can see you can easily bend it. And if the motors will be mounted on there and then I would weigh something, would lift something, it would add a lot of stretching and everything. But we'll see about that when I get to the CAD phase where I design everything. So for now I will just draw this arm in like that, and then on that arm, kind of like this, the motor will be mounted on there in a little box, which also I thought about like making it a bit rounder than this right here, just so it looks better. Then from there will be the second arm, which will also be round to have like a nice transition, which on the front I have 3 servo motors. One comes here to this to move the arm up and down. Then there will be one up here, just imagine it working like that, which will be then controlling the front arm. And then I'm not sure if this little 9-gram servo motor will be strong enough to hold everything, to hold the arm together, or the gripper. So I thought about just using this strong servo motor right here. It can lift 25 kilos, which is probably way too much for this project here. So the idea was that it was mounted on the grabber right here, which I designed last stream. But yeah, this wasn't really working, and I have to take a look at this process, at this state as well, to redesign it. So there won't be any rotating of the arm, so it probably will just be fixed like that to the front lever. And now if we go down and pick something up, we can do that, just picking something up like this, or maybe not, come on, like this, but it won't be able to rotate itself to adjust to anything. So maybe I'll design that later, but for now I will just stick a motor here on top, which will be the servo motor for closing the grip mechanism. So there will be those two fingers. Kind of cursed sketch, and will be powered by this. So if these rotate, those close and open. Here rotate like that, like that. Rotation. Now, where we have defined the basic principle of the robotic arm, I will sketch out maybe a few, see what would fit to the Arduino, what would fit the Arduino from the base plate. I would say that we just start at the bottom, which will be this part right here. I want to make it kind of hollow, so then the center will be the Arduino. I got my Arduino R4 right here. I already used it in like one tutorial that is uploaded on YouTube, and one video or one or two videos I recorded just now. So the next videos will be all with the Arduino R4. I just like it, it's just clean and not just an old Arduino I stole from old projects or from some kid that is like lying around here for 20 years. So you see a big difference in them. Much less power. This one, it has an ESP in it and a big micro computer there, so way more calculating power. Anyways, so assuming this will be how the Arduino will be screwed in there, we'll just measure the holes then. It will stand down here. For the stand we will just go on here, the base layer. The Arduino will be in here. Then what we have to consider is that the stepper motor will be on top of there. And the problem is with just going higher and higher is that at some point the tipping point, the center of gravity, will be shifted much more up, and then if we would to tip the robotic arm to one side to lift something up, it would just dip over because the center of mass will not be down here, and we will have to put some weight on there. So the idea is to make a few arms to the side. In the CAD software I might be able to make it look better than I can here. So you can just add some weights on here. kg, so to add a bit more support, and it would look cool with some legs on it. Then the second layer of this will need to house the motor. So down here will be the Arduino. I'm not sure, I think this size is actually quite good. So now if we just get the stepper motor out here to not the cables with me all the time. Don't know how far above we can do that because there will be more electronics. The I mean, all the servo motors will be wired as well through there. So we have to see how we manage that. Might be... Yeah, I think about the measurement I will worry about this much later, but I think the diameter is quite good like this. Let me just see where my ruler is here, buried under my stuff here. So we have a diameter of what? Roughly 12 centimeters. I think then if we increase that to 15, it should be enough. We also have to see that we don't make everything too big, because then the printing time will be like 24 hours for one piece, and I would like to avoid that, because my 3D printer is not the most reliable one, and if he like fails 2 minutes in this 2 minutes before the print stops, would be quite frustrating. So the motor goes above. In the housing we have to then give it a place where it can fixate the Arduino. The motor then will be housed a bit upwards, so maybe make a different layer for the compartments. Maybe just you print it up to here, then you finish the print or divide the arm into different pieces, or the stand into different parts. One part will be where the Arduino is mounted, the next stage will be where the stepper motor is mounted, so kind of like motor will be mounted here, and then there will be some support down here. Maybe from the center it will look like this, with the holes to mount the motor in. But then we have like give the Arduino enough space to wire up all the electronics. So we probably give it like, if we stick a few wires in there, how tall do they go out? So it's like that. We don't want to bend them too much. We'll just, wrong side. Just go ahead and see. It's, I think giving it about 2.5 centimeters should be enough, which is 25 millimeters, because there will be the Arduino. And we already implemented, I said that the radius will be 7.5. Make it all in millimeters. Here will be 75 millimeters. Wait, I think the radius should point it to the side. I also tried a bit around or tested a bit with technical drawing, and I watched a lot of YouTube videos about it. Just made a few simple drawings. So there will be cool technical drawings I will also do as soon as I get the rough sketches here, so we'll probably have enough time to do that today. I will stream for the next at least 1.5 hours. I will stream from now on to 3 PM, but maybe even to 4 PM, we'll see. I broke yesterday a wheelbarrow, and now I have to go with my father there and we have to repair it, so we'll have to do this later on in the day. But the weather is really crazy today. It snowed for like 2 hours straight, and now it looks quite good, but a few rainy clouds, so we have to see how the weather is then. Yeah, when we have this set up, we will have to make the rotary part. So on top of the motor will be this disc, which I think can be a bit more reduced. At least it's not that big of a deal. So I mean, it looks not that stable. If you see, you have this entire module, and there's like this one tiny slit which the motor will be rotated through. So I think what would be cool if you make the outer layer, which will be also 7.5 millimeters, not 7.5 but 75 millimeters, and then we will add an outer layer through that, and that will be I don't know, 80 meters the radius, 80 meters, 80 millimeters. In the center will be the tiny hole for the motor, but this, if we draw it from the side, it will look like this, of course. But the difference will be, we have this tiny slit, where here will go the rest of the motor, where the motor will stick in. Then our point for the Arduino, it will be in here, and the motor, which will be stuck in here. It's a bit over saturated here, a bit bigger, but I hope you guys can see it. Maybe I'll show you just quickly all the sketches. You see, then this motor will be going and stuck through here, mounted to the sides down here. I think you get it. But the thing is, now it can't tip easily because it is like tightly mounted, or it has a bit of an overhang from here to here, and in the overhang it has the rest of the Arduino sticking up. I think you get what I mean if you look at the picture right here. This is what we design right now, where the rest of the part stands. So this would be the part right here. And yeah, so from there, if we have our top plate, let's just draw it real quick. Let's make it a bit bigger than it will be in the end. Just so there. On there we will need our mount for the stepper motor, for the servo motor. Let's build it here. There will need to go screws, and in here will be the stepper motor. I think I will just, or should we? I think we have 2 people watching. Do you guys think that I now should just start to design the stuff already with the CAD modeling software? There's the base, and then design upwards, or should we just continue designing this arm to the end, make some technical drawings, and maybe don't even start this stream and just make a whole planning stream? What do you guys think we should do? So yeah, I would say that we maybe continue up to this point right here, that we will design the top platform, because the mount will be interesting to design. Yeah, let's just quickly design also the mount right here, which will be on the board. So from the side, I'm thinking that the motor will be stuck in here. I mean, the motor will go here and its handle like that, and it will be screwed through here. There will the screws go, The motor will continue a bit to the back. And then what we will do is, I think, adding also here a bit of an overhang where the motor is in. Also the motor mount, I think we can also design this if we get this far. I have a few ideas for the motor mount, so you won't have to wait, where's the motor? Here. You don't have to go in here. You see those mothers, those nuts right here. It's not focusing. Ah, you got it? Oh, come on. I think you see what I mean. Those nuts right here. Just design their pattern. They have like here this. Is it correct? Now who cares? I think you get what I mean. And we will imprint that pattern right here into the print, so we can just stick those nuts. I think they're called nuts. Inside there, and don't have to go with a special screwdriver in there and tightening them, because there was not enough space really. It was really tricky to mount it, and I think we can design something cool there. I saw this design in the CNC machine me and my father built sometime back, and I thought it was a really cool idea, because then you just stuck everything together, just screw it on, and don't have too much struggling with needing two screwdrivers to tightening it correctly. And yeah, I wanted to try this always, but never got to it, and that's what I definitely will implement. So then we have the base up here. From there on, we will need an arm, which will be a bit rounded, I think, for the base. And here will be the bolts. At this point right here, we can fixate it on those two screws here, and if not, then we will have to design our own screws. But I think there won't be I never designed something like this, so this will be interesting if we do that ourselves. Then on top, I think I like the length of that, because if we make it a bit smaller, then it would look like a bit goofy if we have like these big stepper motors just sit on them. But too long also doesn't look like too nice, because I don't want to have it like this thin stretch. I want to have it like this overhang, where the motor will be mounted in here. That is the idea, that it will kind of sit in here. The mount, that it sits kind of like this, and it has like this squared viewpoint, or squared view from the top. There will be the motor set sit in, and then you can just move it along, and I want to kind of cover the motors, because it looks way cooler if it's just moving without the motors showing really. I think you saw the thumbnail for the stream, and I kind of want to do it in that direction. Yeah, no, it was just me. I didn't have an idea for the thumbnail, or I didn't prepare a thumbnail. I just wanted to stream really quickly, and I just got onto Stable Diffusion and just designed. I just told him it should make a robotic arm. So, yeah. We will just... Yeah, I think that's what we can design. Maybe we'll get to this point, we'll see. But, the thing is... When we go up here again, I mentioned earlier that I wanted to make it rounder than the last one. So the motor mount will be up there as well. but then we will have to make it kind of round, or we don't have to, but it looks cooler to cover the motor up a bit. This will then probably be on this end. The motor then will be stuck through that right here, like that. And then the same goes here, also the motor being put into here. Yeah, I think you guys kind of get what I mean. If yeah, so I think we will start with technical drawing now. You see this, I will pull it quickly out here of the paper. You just mark it, robotic arm. Wait, let me just see that I don't spell that completely wrong. Of course I spelled that wrong. It's sketch like this, sketch 1, and we have 21/04/24. That's the date when we designed this. So now we will go on. Just clean this up right here, or else I can't focus on doing my things. So we will start with the base, which we said is 17 centimeter, 7 centimeters across. Wait, if we just one, we have it like there and down here. We just mark the center point. Then there will be here. And then from this center we will go here. We have to make the center differently. The center will be on here. Then adjust those. And now we will just rotate around the spot. Going here. We don't have to do it too accurately, just to get a rough sketch, and then just draw it around like that. I don't have a circle, sadly. I will have to buy one. I will probably do this week. It's just so I can draw it way better. It will be more interesting then. Oh, yeah, just a circle right here. This will be the bottom part. Then we will have to see whether the Arduino is mounted in here. So first of all, we have a radius of 7, why do I keep writing 7,5 here? 75 millimeters. And then we will have to measure the Arduino. I will take the Arduino R3 because it is better in the center. I think the points still match. So if we go ahead and look, I think the holes should still match. Let me just see if I can find some kind of sketch online. Arduino sketch. No. Holes. No mounting holes. This looks good. Open a new tab. Oh, a nice page right here. I can just quickly show that. Put it into this. So we'll just go ahead and scroll down somewhere here. Yeah, that's good. So we have our mounting board there. Maybe let's first start with the Arduino. We have the Arduino, which is 66 millimeters wide. That's pretty awesome that it is. Yeah, what the whole sketch is this wide from this point to this point. On the left side to the right side. So we will just start with 66, but we're still be there. And then 66 there. Then we're from the top, we're going down. How far? That's maybe let's add a few at the 70 centimeter full right there. It's wide, it is 55 millimeters. Just down to here like that. And then again 7 just to the side. And just like that, going in here. So from this side, let's start from the top. We have from the left side 66 millimeters. 66 millimeters is which is right there. So the holes are located on this area. We don't have to make it point correctly. Let me just switch over to my view again. Maybe so I can also see what's going on here on YouTube. So we have this now. The holes from the top. Do you hear that in the background? So just like that. The holes on this sketch. Then 18 millimeters down we have the first hole, which is back here. So this hole is how far it is. So it has a diameter of 3.2 millimeters times 4 for the 4 holes on the Arduino. And then from the top to draw the second hole we have it's 45, which is right here. Just draw the hole. Then we also have to mark where it is. So quickly giving it a measurement from here to here. It is 17,8. From the top we have let me just quickly go up here, fill that in. From the top we have how much it was, 45.7 millimeters. Then from the left it was like all the way down here to the left. .0 millimeters. So, well, let me see it. Then 18 millimeters down we have the first hole, which is, let's draw the hole. Then we also, okay. Now it's sunny outside. Yeah. So the Arduino down here. I think from here on out it doesn't really make sense to draw it down there. Let's just draw it the center right here, there and there. Then the height was, I said 55. So 2 and 5 will be alright. Or here 1.7, like this. Just make the outline, have it easier to draw. There to there, there to there. Opa, there from there and to here. You know what? Let's not do that on the paper. I mean, we have to repeat the whole process in the anyways. So why don't we just start on the CAD modeling software? It's better. And you can see it better anyways then. So it might be also more interesting to you. So let's just switch to stream again here. And now I will just go into the FreeCAD. It's a completely free modeling software that you can use. And we'll just go ahead. Wait until it's opening. Or until it's open. Cleaning my room. Taking a sip of water. What? It's Bitu. Welcome to the stream, Fisherboat. But I don't know what she's saying. Bitu. So let's create a new sketch. I don't even know if it's called a sketch. Anyways, we'll go into the design part. So it's called. I also just got the software last week, so I'm not that familiar. I watched a few tutorials. Yeah. No, it's not the Onshape, it's a different one. You can get it completely for free. It's an open source software. So I kind of like it because all the ones you can get, like Fusion 360, it all would also be online, and then you would have to see that you're not making over $1,000 a year, or else you would have to pay Fusion 360 $1,000 a month. Oh no, I think a year was the license. And So yeah, and free CAD, you can do whatever you want with it. At least what I got. But I think I won't make $1,000 a year from 3D printing for some time. So anyways, just going with this software because it has a lot of future potential. You can animate everything you do, and that I would want to do is in here. So let's just go. Wait, I think I have it in German. Maybe we just change that. So English. Use. There we go. It's English. Create sketch. Yeah, I was right. It's called sketch. So we want the sketch to be on the XY plane. So now we go and see. We will start off by creating quite a big circle, 75 we said. We will have to, oh no, just yeah, and then we will have to see, if you download the software, you could somewhere, I saw it in a tutorial, change how you operate the scene to different kinds of modes. I used it because here I set it to Blender because I'm quite familiar with the environment in Blender. Before it was like completely different keyframes and I was just messing up all of them. So I set it to Blender. If you download it, you can also set it to Blender and some different Fusion 360, Autodesk, AnyDesk. You can set it to different stuff. I set it to Blender, so if you want to model anything here, I would advise you to do the same. Constraint arc of circle, yeah, that's the thing we want. We want to have it right 115 millimeters across, which should be a radial of, wait, no, I think anyways 150. So just drag it to the side like that. Then in the center we want to create a, do we even want to create a square? And we just need the holes, but would it be cool if we make it like, you see, like the Arduino R4, it has like a little stand on it, it comes with it, it's like CNC'd it out. And my idea was maybe to put out the hole, elevate them a bit, because under the Arduino there are also the connection pins. I'm shit at this anyways. I'm continue using the Tinkercad, the software for normal humans. Yeah, I started off with this as well, but at some point it was just frustrating me because I had like a bit of Blender experience and then there was like in Tinkercad just some stuff that I didn't like or that wasn't there. Nah, I don't think this doesn't look injection molded. Or? No, it could be right. Yeah, no, it's injection molded. Yep. I mean, you can just put it out. Yeah, I know, I just thought because I had a quick look at the back, it just looked like it if it was CNC'd. But no, never mind. So I will create something like this, and I think we actually have to create something like this because of the little pins beneath it. You can see it. Yeah, the little pins down here, which would stick out, wouldn't work if we don't make any extensions above. So anyways, we will create a little center right here. We can remove it later. Let's just make this approximately the size of the Arduino. I set here 70 millimeters. On the horizontal, wait, what was the keyframe for this? Distance, does it also? Oh yeah, from now on I will just use the distance one. It's way easier to use. 55 I said. Why do I just not just use it? I can just measure it, and it is actually 50. 1, 2, 3, 53. The shortcut for this would be K D K D, both. Perfect, the shortcut doesn't bug. So it's 53. No, 53, like that. Only problem with Thinkercad is that it just takes years to load larger files. Yeah, that's also, and I think it's also only web-based, or have they now also got a desktop version? Because this was the most, you know how bad our Wi-Fi is here. So for me it just pisses me off if I'm streaming and I can't just load. That's why I'm not using Onshape anymore. It's a really clean software, but if you have bad Wi-Fi, it's just really frustrating to do anything with it. So from here, from the left to the right, we have 69 millimeters. 69, like that. Drag it down. Oh yeah, okay, only online. Yeah, I fell in love with it as well in the start when I was just creating some things, but as soon as you try to make, or at least for me, I mean it's like 3 or 4 years back now, when I started with 3D printing, I really enjoyed it because it was so easy to do anything with it. So just getting a cube in there, making some holes in it with cutting it out with booleans. And yeah, maybe I'll take a look at it sometime, but for now I will just stick to FreeCAD because it has like really cool things. Can you animate the in FreeCAD in Thinkercad? Because that's like one of the biggest things I was looking for in a CAD modeling software. There's also a really easy one. It's called Plasticity. I just saw it. It's really intuitive. I haven't tried it so far. Maybe we can just see if there's some good thing. Just scale up something like here. Can I? Okay, that's wait. And now I just go ahead and just scale this. Yep, I think that's something for you. Here it's called Plasticity. I just type it into the chat. If you're not looking for any plus. Wait, I just sent. I want here, just in the chat, like that. It's I haven't used it this much, but you see how fast it was to just extrude something, and you can also do some measurement in here. It has like all the functions you need. It's a really clean interface. I think also it's really new, and maybe in the future they will also add animation or something. But yeah, you maybe can take a look at that and watch a YouTube video about it, because it looks really cool if you just want to model. Yeah, now it's boring to go back to this shit show right here. Yeah, I'm not sure if glass fiber, I think it's called.
Glass fiber.
Glass fiber, yeah, right. I'm not sure. I mean, we're moving out of this house anyways to a different house where there's no glass fiber yet. But we have to see it, so maybe it's not worth it, the investment to buy this box right here. I don't know, I have to ask my father about it. Yeah, the software, it looked really intuitive, and I was already considering making all my projects from now on in this one, but then I noticed there's no animation tab. I'm not that good at animations here, and I probably won't do too many, but it's really cool if I make a YouTube video and I don't have to film everything on online, or if while I edit I notice, oh yeah, wait, I forgot this scene, or I forgot to make a animation or film one prototype, like from here, example, if I have this part here and I just have assembled this part and I didn't make a video, I can just go in the animation tab, make the quick animation of rotating this, and I have footage for the video. And also it's just fucking awesome to build some make animations. It's just a video game then, especially in the future. I want to make like bigger projects, maybe some automation systems, and the idea of just designing thousands of pieces in here and then just sticking them together to be a fully animatable I don't know, factory is like really cool to me, or really appealing. So I hope at some point this will be the level I'm at, but for now we will just stick to the drawing board here with Arduino. So yeah, now we have our board set. From there we need to make the holes. We already had... But am I blind, or where's the hole? Oh, why is it there? Doesn't make any sense. So there is one hole on the Arduino which is up here. Then there is one hole which is down here. One which is roughly there, and one which is roughly there. So we will just go ahead and pull up our data sheet again, if I did not close it. Yeah, no, I still have it here. What is this? Why do I have... Oh yeah, okay, yeah. So we have the data sheet. Let me just drag it to this side so I can more easily adjust the holes. I will take this constraints menu from here. I will start off by defining the size of the holes. The holes right here on the Arduino, they are 3.2 millimeters wide in diameter, but it should be 3.2, right? Yep, fits. But there's the problem that I don't think I have big enough screws for that. Let me just see it. I have I think that right here is one of the best investments. It's like a screw set I bought, 20 euros. You can just take a screw in, just measure it, and it's so good to have like a screw set here and just being able to play around with stuff. So this would be too big. Wait, let me just see. The camera down again. So we have like, it's M4 screws, machine screws. They come in 2 millimeters diameter, 3 and 4. And usually you use M2 screws for most projects and everything. But I think that M2 screws are not that good because they're really small, and if you're like printing something, it's just you print something and the printer isn't that accurate that it can make this tiny screws. It can, but then maybe the hole is like fixed because there's one glitch or something. It moved a bit, and then you can just throw the whole thing almost away. But those M3 screws are a good size with the Arduino, with the printer, and the M4 is just a big thing. So, wait, am I just stupid, or do I still have to... Wait, do they not fit in here? The Arduino 3, you know, I think the holes of the pre-made board are a bit smaller than the 0.2s, but they would just fall through, I think. Here. Oh. No, they're really designed for the M2 screws, okay? That's interesting. Do you then fix them to the back? I guess so. Anyways. In the wrong spot. Again in the wrong spot. Oh. Yeah, the new robot from Boston Dynamics. Just a friend sent me this. It was just the goodbye from the old robot. And I was just watching, oh yeah, that's sad, why they're stopping. And I just went on their Twitter page and I just saw this video. And yeah, oh yeah, that looks quite realistic. And then I just looked at it, watched the whole video, wow, that's so cool. And then I looked at it again and then, what the fuck, it's so realistic. And I just had like a total goosebumps, because it's actually like the size of a human. It's not like huge motors everywhere. It's just the normal size of a human, and they could have probably built it into, I mean, the legs, you could just disguise it as a normal human. It's so fucking insane. I'm telling you, 50% of the people you talk to are just actually Boston Dynamic robots. I'm telling you, man. That's such a crazy video. Hey, let me just pull it up on the stream right now. Here. Boston Dynamics Atlas. Here. Oh, their introduction. Oh, I saved it for later. Do they have it here? Yeah. That is so unreal. No. I mean, the quality is so good. It looks like 3D print, and it looks like rendered. If you look at the head, I mean, it's so clean. That's crazy, this. Yeah, the future will be crazy. So it's actually Terminator. It's not even a joke. Yeah. Will be an awesome future, I'm telling you. But the screws, I will design it with 2.5 millimeter. Oh, not 25. It's still 2.5. Okay, it's still got the... Yeah, don't piss me off here. You have 2.5. Yes, it still uses the comma because I just set the language to German and I have it. In Germany we use the point, not the point to say decimal numbers, we use the comma, so it's a bit different. Why you use this? It's just confusing to always switch between them in different programs. But I just said comma 2.5 like this, and this as well 2.5. like this. Yeah, that would be. Wait, is it a robot? Yeah, right here. Smoking a big stogie. Yeah, good. So we have one pin that will be those holes will be drilled down, but I think that's actually stupid what I'm doing right now, because we're designing the holes to be 5 millimeters big, and then when we extruded all of that up, we will change the 2.5 or drill holes downwards, so we have a structure there. I'll show it to you in a second. So now we will just have to say the distance from this point to this point. That is the problem right there. Wait, if I just from here to here. Okay, this is on the sketch. The height is 2.5. Yeah, that would make sense, but we scaled up the view, so that's not that bad. So from there, from the left, it is 15.2. Like this. Let me just make it a bit easier to view. Like that. Then we do the same thing for the bottom. It's okay, no, we don't do it like that. We of course have to go from here to all the way up here, and there it is 50.8. No, not 55. 50.8. And then also on the left it is, yeah, again 15.2. Then we have those which are 66 millimeters away. The same goes for this one, 66. Then from this to the top, yeah, they gave it in the top, is 17.7 or 17.8 if you round it up. And this from the top is 45.7. So now we will just have to make it a bit easier to view what all the sizes are. All of that. Easier. There we go. See you either at the... Okay, I see you, man. We have to hit the gym together sometime. And I think in the next time we will play Airsoft, I will be there as well. Not sure if you're still watching, but yeah. Next time I'll try to be there. If the weather isn't like this, snowing the whole day and then some... then suddenly going to like 20 degrees. Awesome weather. So there the... like this. Just configure it the same way everywhere. Drag this a bit further back, this also a bit further back. Then we can just give this more space. We give here a bit more space. Then we will draw this out a bit. And this is fine as is. So now what we do, we have the holes set and everything. So now we can click on close. We now can go ahead and go on extrude, which is this right here. Just click extrude. Okay, then maybe not extrude. Maybe I first have to say... Why can I extrude this now? Wait, hello? So now if I go on to close it, extrude... Oh, please don't tell me that I... Come on. Let's just go and try to do another one. Create body, create a sketch. We want to make a sketch on the XY plane. I want to have a circle that is same size. This circle then will be here 150 millimeters. Now we can go on close. Can I somehow make this sketch invisible? Line rename. Hey, oh wait. Please don't tell me that I think this broke it kind of. Base mount. Oh, come on, why? So just select this sketch right here. Here, toggle visibility. Where is this now at? Here. There is toggle visibility in screen view. No, this one is like that. This was the extrude, right? Okay, you see the problem why I have a few. I see here can't see anything on my screen. I want to make it quickly invisible so I know. So now if I body, there we go, now we have something. We want to make the bottom 5 millimeters. On top of that, please don't tell me that I have to redo that. I think we have to create a if I make now here delete. So let me create a new sketch. I want to make the sketch on top of the body, top of this plane. No, wait, how was I doing that back then? Body, okay, this won't work. There we go. Sketch 2, like that. Plain face, yeah. Looks better. Oh no. Okay, so we have to copy all of that over. Do we? Now can I just the body? No, that's not working as I wanted it to. Now we will just have to delete that. Put the sketch back in here. Up, like that. So now on here we will just go ahead and create the thing again. We start again off by creating a triangle. This time a bit more accurate from the start, or a bit less accurate, because doing that again will take a bit of time again. So now we have like 70 millimeters in that direction. Wait a second. Okay, you know, I get what the problem is. I had considered the wrong thing. Here's 70. And the height is 55. Now we can just go ahead and make a few holes. One goes here, one goes here, another one there and there. Then just quickly go ahead. We will make this 5 millimeters, 5 millimeters, 5 millimeters, and another 5 millimeters. Then we will just give it a quick to this top will be 2.5 5 millimeters. There to there will be 15.2 millimeters. From this point to this point will also be 15.2 millimeters. Then from this point to this point It is, wait, wrong plane. We need to take this one, and this is 50.8 millimeters. Then we have from the left side to the right side, the right holes will be 66 millimeters. This will also be 66. And then to the top they are 17.8 and 45.7. Whoops. Wrong plane. 45.7, like that. And then we have our sketch again. Now what we want to do now is we want to select this hole, this one right there, this one, you selected object, so using the shape line there. Huh? We just... What is the shape line there? Nope, I don't want to do that. I want to select this. Here's the face. Current suggested. And nope, that's not what I want. Why are there two holes now? Oh, come on, why? And then we have this. Which also... Nope, no, why did that happen now? Are you kidding me? Oh man, you see, I'm struggling with this software a bit. And I mean, it's part of the process. So, that doesn't work, so let's just delete that one. That one is somewhat okay. Just take it backwards. From the bottom, we will just I want to take this sketch. Wait. Let's just take a look if we can find a tutorial online. It is FreeCAD sketch on face. Okay. Don't want to get copyright strike here. Thank you. Okay, still no music. So oh man, Okay, okay, I get it. I think I get it. Oh, so if we now say it's this sketch right here, selected the top of that, then we want to map sketch to face like that, and the sketch we want to map is the sketch, just the face, and there you go. That's how we do it. Now we quickly go on the YouTube video again. We thank him for that, and we hope that that's actually what we wanted to do, and that this hopefully helped us. That is perfect. We will probably come to this guy a few more times in this robotic arm period, but for now we will just I want to extrude this now. If I want to go, we will just quickly go again on the YouTube videos and just see how we can actually solve this. FreeCAD, extrude face, sketch on face. Maybe that would help us. Yep, let's just this guy again. Haha, he's good at this stuff.
FreeCAD basic tutorials how to use extrude command to convert sketch into
Love this
3D
guy.
objects. Okay, in it I will create new drawings and you can change into part designs. Click create body, create sketch, and I will choose a top plans. You can create the sketch, extrude the sketch. You can click these icons or you can click at these points. You can click. It will be automatically extrude, and you can set for length in it, like I will set into 20. It will be extrude 20. You also can use these symmetric plans. It will be extrude in from the center point to the top 10s and to the bottom 10s. If you uncheck, it will be going to the top 20. If you done, you can click OK. You also can select up this face, and then you can create sketch like here. And
Okay, here if you go here, task, and then create sketch. But if we go in here in the sketch, we will just quickly see this. How about we do that just over again? Well, why not? Why not? So, this is our top. On there we have a create sketch.
create circle, cut this face, and then you can create sketch like here.
Okay, he just didn't get the window. Your selected geometry are not part of the active body. Please define how to handle not part of the active body. Delete that. We are in this body right now. So we will take this and we will task, create sketch. There we go. So now, please don't tell me, wait a second. So if we now select this body, we can quickly delete that one because we don't need that. So now if we press on this right here. Oh, come on, man. Oh, it could be so easy, you know. Could be. But no, we will always have to do it more complicated. I delete that circle. We will have left only this view. We will have left the sketch. We can just say extrude, and it will tell us that we are doing some bullshit stuff. I just want to select this face, I want to select this face. No, okay. We go back into the sketch and we'll see if we can, if we are able to get rid of those faces right there. Delete, delete, and delete. So the measurements are still there, but we might have to redo them if that doesn't work. Just go quickly onto sketch. That looks better. Give us a better view on that. We want to scale them up to what do we want to scale them up to? 5 millimeters should be enough. Let me just see how far this pin goes up. We just go in here and 5 should be we make them to 3. Will be less material to print. So the 3. Okay, then we will create a sketch, face and oh man. Okay, so we will create a close. No, we want to delete that real quick. We now select one of these and create sketch. Then we will go ahead and set a reference point. There was somehow where I can create a reference point at the center of these. And this. Okay, now we will have to FreeCAD reference point from another sketch is what we're searching for.
Hi everyone, and welcome to another episode of the Learning FreeCAD for Beginners series. In this tutorial, we're going to be looking at reference constraints, what they are, and what they can be used for. If you're seeing you want to donate to the channel, then you can do so via Ko-Fi or Coffee at ko-fi.com/MANG0 or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content can be found. So what is reference geometry concept? Coming to the SketchUp, I'm going to create a point with the point in the symmetry of the length. Notice you can see it down straight hands the different side back they would plot any as
I want to see as soon as you create the next sketch.
And add a constraint and set some length. I get a line where then now as need meters and the main here constraint. Circle some diameter across here to Z. So length. Let's give you an idea of how to.
Good, that's just not what I want.
Hello everyone, free cat, we draw rectangle in it. Click close and use pet tools to convert cat body. And after it,
I think he got
you
it.
can select, like I will click at this face, click at this icon, tap Binder.
Oh, the DC link. By the way, welcome here to the stream. Wait, I can send you the Discord link. Isn't it in the description? I mean, it should work, right? Wait, no, the link is not working. Hey, I'm sorry, guys. I think I thought I had created the link for permanent. Please don't tell me it's again. Here, link. Let me just check if the links from the YouTube video are also not working. Because last time a guy told me that it wasn't working, and I went on Discord and said that the link should be permanent. But apparently it isn't. No, this one is where, yeah, then I just didn't change it for the... Wait here. Then I'll just change it in the video. Yeah, I'm sorry, guys. Here the videos for all the ones who maybe want to join the Discord. The link should work now, I hope. Yeah, that looks better. Yep, you can join now. It's... thank you for mentioning that. I would have streamed for the next few hours without even knowing that. Thank you a lot. So here let's just see. Wait, what's what did he do?
And then click OK. Now you can
Why?
add this body one external geometry in this.
Oh yeah, I found it, and there we go. Another awesome video. So we have the thing that we are looking for, this right here. We'll see it if we delete all the points. We'll just go delete. And this will also be deleted. Then we will just click here. Or maybe not directly, but circle, circle, circle. Perfect, it's even better. It's even better. Let's go. Now we don't even have to create the circle ourselves. I hope that the circles won't change if I now rescale them. Oh, that's awesome. I somehow love to just edit on those other circles. I don't know. It's... Does it change? 2.8? No, it doesn't. Okay, maybe it's not even better. Let me just see. And for some reason you can't change them. Okay, perfect. But I think... Okay, doesn't matter, we just create our own rings instead. But this time with... our own, or maybe not. Yeah. Hey, thank you for joining the Discord server. So, wait a second. Okay, so then I'll stream for 50 minutes now. In 50 minutes I have to go off, and I will try to be back after I'm finished. I broke yesterday a wheelbarrow, and me and my father have to go and fix it now. It's like if I come back, I'll take a picture and I'll show it to you what I was doing. But yeah, I basically broke a wheelbarrow, and now I have to repair it. Create external geometry. Can I do the same thing? Extend edge, split edge, something like that. No, that's not working. Expand external geometry. Perfect. Yeah. Don't. Why won't you change now? Well, what's the problem now? God damn it. Why it was so working so good a second ago. Come on. Delete the sketch. Again, we will select this point, and we will just say that we want to create an external geometry from that. I don't think that's...
Okay, you can draw circle or the other objects. You can set for distance in here.
Yeah, but it's not really what I want, oh man. So if I just go in here, we can just... Yeah, but I don't think that's the thing that we'll need to do. It's how do we go about this? We will... I mean, because that's not the point right here. So I think we could go back into the other sketch, which is this one right here. No, that's not this one right there. It is the one right here. And we can just go and just say point, make there a point, make there a point, and make there a point. So now we have more points in there. So now if we were to press on, maybe not, was an idea, delete, maybe if I redo the sketch, not that I will do another sketch. No, of course it's not how it works. So I will make this, create sketch, then I will create yeah, no, that's not how this works, sadly. So yeah, let's just see if we can make a circle above this. Just go ahead and... okay, at least this works. Okay, this works. So now we will just go stick with that. And so we now know we can create geometry, copy all the geometry, but it's sadly not that easy, as I thought it would be, to just drag out the point or make a reference point. So we have to make the whole reference there. But anyways, so we will scale this down now to 2 points. I think to fixate the... I mean, we don't have to make too much wiggle room in there. This will be 2.9. This will also be 2.9. 2.9. And this will be 2.9. So we have 2 millimeters to the outer walls there, and what we create by that is we want to now I mean, now we know how to make the revolution, but that's not what I wanted to do. I wanted to do the... here. That's the one. we want to take those screws right here. So just to show it to you, we have these M2 screws. I don't want to drop them. And we will use, I would say, they are 1 centimeter long, because the whole plateau now is 7 millimeters long. We will have to make those. They are 5 millimeters long, and they are probably not even fitting through the roof right there, or to the Arduino, not enough. No, they should actually work. Yeah, doesn't just reduce the printing time if we make them even smaller. So let's just say we want to bore all the way to the 6 millimeters, 1 centimeter before it cuts through the whole thing, just like that. And that is what we got. So we just have the Arduino field right there. Now the next thing we want to do is we want to create the outer line. Because if you remember, we wanted to extrude that point up. So how much do we want to extrude this up until the, at least for 2.5? No, sorry, not 2.5. We want to scale it up to 25 millimeters. Because if we take a look at our plan right here, just open up OBS to see, we have like multiple layers. On this layer of the baseboard will be the Arduino, and on this on top will be the stepper motor, the one we have right here. And it needs some space between the Arduino because they will sit above each other, and now we have to put some space in here so we can just still wire everything up without running into problems there, but still mounting the motor. So what we can do is we scale up this build for 2.5 centimeters. Then we will create a new sketch in here. This sketch then will have the outer diameter of what will we give the diameter. We will, the Arduino has enough space in it, but we don't want to have the walls too big to reduce printing time. So we will just go ahead. What do we give it? We give it 40. Yeah, 1 centimeter walls should be not too much. Not 140. Here 140. Oh, that's 150. 140. And there we go. So now when we go back, we will again go ahead and say cut, and we want to cut down to 5 millimeters. Oh, not 2.5, again 25, same problem. Same thing I typed in last time. Cancel, remove, and this will be 25, and of course our holes are gone. That's not what we can do. But this will actually be deleted. And there we go. Sketch 3 will then also be deleted because it's no longer functioning. So we will have to create another ring. Let's create another sketch. This sketch will be from the center to there, and from the center to our 405, 150, 150, and then the 140. So now if we go ahead, close this and press on extrude, that's what we could have done from the start. But yeah, just experimenting here to learn more about how everything functions. Now we have to take into consideration that we need to get the cables in there. On the one hand, we could just stick all the cables we would need from the top into the motor here, from getting it to the top. But then the thing is, you know, I think that should work. But let me see what this... Yeah, we can just use extension cables for those to connect them. No, it's raining outside again. Well, let me just... Yeah. So the thing now is, we have the wall around here. Arduino will be put in there. That's our first body, or body. So the next thing will be to create the motor mount for the stepper motor. And we will do that by going ahead and designing a place where the motor will be stuck into. So this off center. Okay, I'm just talking shit at this point. I will just create a new body. This is the base Arduino, and this will be the step motor mount. Then we also have to see how we can include that. By the way, can you guys tell me how the audio is, if it's too loud, if it's too quiet? I'm streaming 2 hours and now I'm asking. Perfect. So yeah, just tell me please how the audio is, if I should do it a bit louder, microphone further away, closer to me. Step motor mount. Base stepper motor mount, and it's not stepper, but it's who cares. Stepper motor mount. From there we will so just go on like that. How do we... You know, that's now a bit more thinking here. Yeah. Base motor mount. It will be making another sketch in here, of course. Create new body. Yes, stepper motor base mount. So on the X and Y base plate, and then we will just go ahead and I need to see if I can somehow make this one, this part invisible. Yeah, chill, man. A base. Okay, I can just. If I go here and say toggle visibility and preview, it won't be. No, if I. Yep. No, that's not how this works. So. I want to make this part kind of invisible so that I can just easily control how no. The Arduino is mounted in there. I want to turn off FreeCAD disable bodies. This guy again.
Hello everyone, welcome back with FreeCAD basic tutorial how to hide object. I will create new part and use part tools. I will insert this box tool, also the other like a cylinder and sphere. Use transform tools to move the cylinder, and other for sphere we can move into green axis. Type, right click and click toggle pitch.
Okay, so if we change into part, toggle visibility, that's what I wanted. So now if I go back into part design, if I go in here and create a sketch, X and Y plane, and I say that I want first of all, just for viewing everything again, we want to create the outline, which is again on 150. And in there we want to create our motor mount. The inside, I just realized, is also I'm just thinking, sorry, I can't talk too much if I'm thinking, so it's a bit boring, but try to do my best. And I just saw that I didn't make this really centered, so let's just make this again 150. This was 140, So we have our 2 circles because we have, in the end, we need to mount them together again. So we can just go ahead and print the motor mount. Not printing. We're not printing yet. So what we do is we create a box that goes from here to this side. Then we will set the length or the height of this to be the stepper motor side. But we have to see that if we, because the stepper motor, it's not centered directly, it is a bit offset here. If you see the center of the where the screws would be here, but the motor is up here, so we have to, how far is that up? That is up about 7.5 centimeters. So we will scale this I'm thinking, no, that's not how this would be able to work. So we have to scale it from here. From this point to this point. We want to have it in the center, the very least. God damn it, man, my brain isn't working here. 3-4 centimeters wide will it be, 4 centimeters. So we start by fixing this. This will be 40 millimeters. Then the center is at 2 centimeters. Will the motor be mounted? And then from the center, the 2 millimeters, we have to subtract 0.5. So we go to the center and we say that it should be 7.5 millimeters to the bottom, and then from here we will create the hole for the stepper motor where it will be placed into. The hole will be, and we have to see that we don't make the hole too big. The hole is from here to here, 2.8 2.8, which is 20.8 millimeters, 28 millimeters diameter. That is what we got down here. At the bottom we have the stepper motor. So the range from, let's say that we give it 2 centimeters. Okay, then completely offset it if you want to. Thank you. The distance from this to From this point to this point should be 0. Okay, then don't make it 0, thank you. Nice editing software. Make it 0.01. There's no smaller scale really. Make it delete, and I'll just drag it myself down there. I'll just go ahead and delete that. Drag the point again in the center, like that. Again, really 20. It's more like 1. .8. And the height will be from the point there, at least has to be 10. Like this. So the cables will go through there, and then from there it will be 5 millimeters to the cables. They will be able to go through there downwards. Yeah, that should work. Yeah. What we have is this motor being stuck on there. The holes are a bit trashy to make, I think, or to get correctly. So we have the 2 holes which are on that line and on that side. So here we'll also use the 0.3, I think. They're a bit jiggly, I think, so maybe the 4 ones each. Or even the 4 ones are a bit janky if you take a look like that. They are a bit too big, right? Yeah, screwing it on like that won't be the best idea, but it would work. Okay, so then I think it's set. We will use 2 ones, the 2mm ones, but we will choose one of those little things you lay before it to make a bit more place. Yeah, should work. Should be able to work. And there we go. So now we will first have to make the rotation. We use the 3mm ones, so 2.9 again. Those will also be 2.9. And then we'll just quickly set the side from this to this to be, I mean, from each other they are 3.5, which means 1.75 from the center. No, it's 17.5 from the center. Same on the other side. 17.5 from the center, millimeter from the center. And what the height goes on now here. Yeah, what? No, I want the height. Leave me alone. So the height from this point to this point should be 0, and from this point to this point also 0. So it's like that. Now that will be where the holes go through. So we go ahead and take a look how this looks. It's a good word combination. So now we will okay, this for some reason won't work again. So like that. How do we go about that? If we just say this. Why is it working? Isn't it working? Wait guys, I'll be back in a second. I have to check something real quick. Okay, so I think we will have to end the stream right here. I just want to see if what the problem with this is right here. I just want to try to I don't get it. Why is it a glass? Okay, yeah, he's crying around because I set it to 0 here. Cancel. So we go into here and 0 is not available. And find class, so we just go delete those two. I mean, now he copied already the information, so we just have to like 7.5 and again 7.5 like that. Press close. Then he is complaining even more. The 0 is not a sketch 4. 31, which is is set for right. Wait, app. Where did I set anything to 0 millimeters? Okay, this one is crying around. Okay, so this might have been the problem. Actually, I'm not sure. I hope so. No, apparently it's not. Why is there still the... Why is there... And there is nowhere any 0. 22, everything is set to something. Violation, oh man, I just wanted to quickly build all of that, extrude it, and then I thought we would be fine, but no, of course it's not how this works. Can I somehow combine these? Combine sketches.
And we had hurricane. So fully constrained that shape, how it's oriented. Create a part, going to create a body. And for the sketch, which is not important, but something so that we can see how it's oriented. Just create something quickly.
I wanted here this tool, okay, and he used the tool. So like that. I hope this works like it should. So now if we were to just select this right here, FreeCAD, like right here, FreeCAD, oh please no! Oh man, I'm stupid. Oh, I'm so stupid. I can literally do the whole thing again because I again didn't really check what I was doing. So we can actually remove this part, this one right here, this one, here, 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 this one, this one, this one, and with that we have our first scale set. Now if we go ahead and so something is copying and pasting, I don't think so. So I think we have to design that again. Like that. Then this down here. This can all be redone because I didn't really check what I was doing. But or it does not have to be redone. I just fixed it. Let's go. So we want to scale this up to be, I would say, .5 millimeters will be okay. Just for mounting it, testing everything. Same thing how this went. If I just take a look, this one is 2 centimeters above, so I quickly have to go into the base mount again. We go into the parts. In the parts we toggle visible, then in the visible we go on to the sketch. In the sketcher we again close it, we go into the part design. In the part design we have the extrusion right here, and there I actually want to extrude this out to be 35 millimeters on top. And now with that I will leave you to it. If you enjoyed the stream, I would appreciate if you dislike the stream and maybe check out the Discord server. There will announce all the videos, and I hope it grows so we can find each other here, support each other with projects, and just chat and have like-minded people in the community. And I think this would be awesome. So I thank you for watching the stream, and I'll see you on the next one. Bye bye guys.